today's Energy Central webcast entitled Leveraging Digital Tools to Plan, Build, and Deliver the Next Evolution of the Grid. Now I'd like to hand the floor over to our moderator, David Wagman, to kick things off. David, welcome to the event. You have the floor.
Great, thanks very much, PJ. Hello, everybody. And again, I'm David Wagman, and I will be your host and moderator for today's session, which is brought to you in partnership with Bentley Systems. As always, my colleague PJ Davis is standing by for additional help if you need anything. We'll be taking questions from our live audience today. So as you think of something that you'd like to ask, please go ahead and type it into the questions bar, and we will try to get to as many of those questions as we can. So the energy transition impacts all aspects of energy production, delivery, and consumption, and exposes the drawbacks inherent in outdated, time-intensive workflows. To remain competitive in this dynamic environment, utilities are rethinking their approach to digitizing documents and data to provide powerful features that guide future projects, identify maintenance priorities, reduce outages, and increase revenues. Today, we'll explore key factors driving the energy transition, dive into how utilities are expanding and integrating their use of data-driven technologies, and showcase some of the strategies that utilities can begin to put in place today to bolster their competitiveness in an uncertain and dynamic market. So now let's get started. Let me introduce our two speakers and invite them to spend a couple of minutes telling us about their work and how it relates to today's topic. We'll start with Dave Lewis, product manager at Bentley Systems. Dave, go ahead.
Hey, David, thanks for having us on here. As stated, my name is Dave Lewis. I'm the engineer here at Bentley Systems. I've spent over a decade in the electrical power systems analysis, and I primarily support our electrical analysis tools for that. Also like to participate in some of our societies like IEEE and AMP conferences and societies.
All right, and I'm Brad Johnson. I'm a director of energy solutions with Bentley Systems. I'm very fortunate to be teamed up with very professional colleagues like Dave, who we were just at IEEE, and I think, Dave, you're very humble. You have quite a following in the industry with all the work that you've done. And that's really emblematic of our team. We really do have a really amazing collection of industry professionals with, in many cases, many decades of experience. And so, David, thanks for being here today. Thanks for having us to help explore this topic.
Let me come off of mute and thank both of you again for those introductions. And Brad, I wonder if you could talk a little bit about some of the predominant trends and challenges that you're seeing impacting utilities today. Can you give a little overview on that?
Yeah, I'll be happy to. Maybe be good to start with just a little bit of background on Bentley Systems as a whole for those who are new to the name, or maybe could use a refresher. You know, we're a global organization with over 5,200 colleagues. We're present in 194 countries, and I really think tying our expertise and our mission to improving the quality of life through our contributions to the world infrastructure. That's a lot of what gets a lot of us out of bed every day in all the different time zones to kind of continue to address these challenges we're going to talk about. You know, we really guide ourselves on being connected to our user community, a shared sense of responsibility in our impact in driving innovation around infrastructure. And then, you know, like I was saying before, it's, as it says below, we're motivated and passionate about those particular things. I think it's also good for us to maybe frame a couple of things. What does energy actually mean to Bentley? And depending on which, the context of the conversation, we really look at it from three different key areas. So we look at energy production, so your traditional thoughts around how we not only generate electricity, but how do we generate other forms of energy, whether it's traditional hydrocarbons, harnessing the Earth's heat as a source of energy. Is it leveraging, you know, these resources for other purposes other than just heating and cooling and cooking and manufacturing? And we also think about how do we connect all these energy production resources with energy delivery. You know, in electric, it's transmission, distribution, substations, increasingly storage and other components. but it's also pipelines and other forms of distributing energy. And we also have an eye on the consumption side as well, because consumption is driving as much of the change in the grid as the way and where energy is being produced. So we really spread our capabilities across all of these, and this is going to help inform the discussion we have today. Not only are we thinking about how to efficiently design a feeder coming out of a substation or HVDC between two regional interconnection points, but we're thinking about what's happening on either end of those interconnections and how it's driving the decisions that have to be made. And really, when we think about digitization, there's really 6 areas around digitization that are driving it. I'd already talked about the energy transition, not just in how energy is being produced, but how it's being consumed. We'll also look at, in a lot of our solutions and technology, how do we modernize the existing grid we have? We talk a lot about reliability and resilience, but we also need to keep in mind flexibility and designing adaptability to the new evolution or new generation of the grid. And a lot of these things also are being driven by how capital investment is being viewed, changes in how utilities and infrastructure owners can capitalize, new rules from the PUCs or other global governments' investment in infrastructure spending. But then we look at what I would call more maturing technologies like smart grids or microgrids. And I talked about reliability and resilience, but talent and upskilling is also a key driver. And how do we help utilities, engineering firms, and others prepare this next generation of people who are joining people like Dave, Dave Lewis, yourself, David, and myself in this industry, and really creating a lifelong career. So there's a lot of things, a lot of excitement, it's a lot of work, but it's the kind of stuff that I think gets a lot of us out of bed in the morning, like I said before, and we're pretty excited.
Absolutely, good stuff. Yeah. Well, let's drill down a little more deeply into how tech is addressing these challenges and trends, because that's kind of the heart of what it is we're trying to discuss today. Brad, do you want to take a first stab at that, and then Dave, I'll invite you to contribute also on that.
Yeah, absolutely, happy to. So there's a lot of different trends happening right now. We've talked for a long time about decarbonization, and that's obviously still driving a lot of activity that's taking place, not only in energy production, but like I said before, storage, how we're building this new generation of the grid to move larger and larger quantities of energy around. We're also seeing explosive growth in demand, driven not only by electrification of different, transportation and heating, cooking, electrifying traditionally carbon-based manufacturing processes, but we also see needs around energy storage. We see explosive growth into data center space. Not everybody thought it'd be Bitcoin that would do that, but it turns out it's actually AI that's driving the explosive growth for demand. And then also, we've been talking since I've been in the industry about the coming brain drain. It's basically happened. And now we're in a position of having to attract new entrants to the market. So as we look at solutions, we're not really able to just say, well, that's how we've done things for 30 years, because this next generation of colleagues, they won't tolerate that, and they'll leave the industry, and we'll be stuck again on this hamster wheel trying to find new entrants. But those are just a few of the themes, I think, that are driving a lot of discussions we have, not only with utilities and engineering firms, but also with regulators, policymakers, and those sorts of folks.
Mm-hmm. And Dave Lewis, what can you add to that on how tech is addressing the challenges and trends that Brad outlined a minute ago?
Yeah, as Brad mentioned, there's a growing demand of electrical power, and not only that, but we have a huge amount of aging infrastructure, and both of those things coupled together make for a lot of work for power systems engineers in the near term. So in order to accomplish those things with less people, we need to have better tools in order to address those challenges successfully. And part of that is simply being able to develop our designs more efficiently and reduce errors. Part of that is training engineers more efficiently as well. So having a tool that educates at the same time as delivers is a huge benefit to our industry.
Mm-hmm. There still are barriers that have to be crossed for utilities to adopt 3D design. approaches. I know that Bentley's done some research on that topic recently. Can you just introduce a little bit about what that research has shown in terms of barriers to adoption?
Yeah, what we're finding out is that from a barrier perspective, some of it's tradition. So there's a lot of comfort in the ways things have been done in the past because it has worked in the past, and so that is one of the barriers to some of the technological advancement. I think it's also a way to put a little bit of theme on that. Sometimes it's hard to remember that in order to win the marathon, sometimes you have to stop and retie your shoes. And I think because of the issues we brought up at the very beginning, we're all being asked to do a lot more. Us as a technology provider, we're constantly being asked to do more. We're constantly being asked to help our customers and our user community manage their budgets. And we have to take a stop and a breath to evaluate, are we doing the right things? And I think utilities, engineering firms, consultants are starting to realize they have to do the same thing, because that was one of the other barriers listed is I just have too much work to stop and do something at all different, even if it does end up making my work easier. I think those are some of the key drivers. There's one other one, and it's risk management. I'm not saying risk avoidance or risk ignorance, if that's the word. It's that utilities have to start to evaluate, and this was brought up. Risk does not just exist in things like cybersecurity risks and things like that. If we're not as an industry able to address these challenges, the real risk is quality of life impacts based on undersupplying energy where it's needed, designing a grid that's not resilient to changing needs, meaning we have to keep reinvesting in reconstruction every time a new technology comes out. So there's all these different things that I think came about in that survey that utilities and engineering firms are admitting, hey, these are the things holding us back, and how can you help us get past them?
Yeah. And Brad, I appreciate your reference to marathons. I used to run marathons and was always stopping to tie my shoes, so I appreciate the connection. Well done, well done. We're going to ask the live audience today, and PJ, maybe you can bring this up. We've got a poll question because we wanted to find out from our live audience what percentage of your deliverables are currently in 3D models. And you can go ahead and make that live so that folks can start answering it, PJ. You can select from 0 to 25% of your deliverables, 26 to 50%, 51 to 75%, and 76 to 100%. Just interested in finding, and then I'll ask Dave and Brad if you would comment on what the results turn out to be and how that kind of meshes with what your own research has shown.
Yeah, I'll be happy to.
Yeah, we'll give it another couple of seconds, and then PJ will put up the results, and we'll see. There we go.
Yeah, this is very in line with what we've been hearing as recently as this week in conversations with some leading global engineering firms. And if you had asked this question 5-6 years ago, you would have seen closer to 1% in that top tier. It basically would have all slid, and the results would have all slid closer to 0, really. And what's happening is utilities and engineering firms are getting to the point where they're starting to adopt 3D models in different ways. So not necessarily going full 3D in every deliverable or every work product that's used to do grid renewal design or grid work. They're finding different places where it's easy or low-hanging fruit to adopt 3D methodologies that can then, as experience and insights are gained, be adopted more widely across all the different types of work that they're doing. So yeah, I'm excited to see 19% and 14% in the 26 to 75% range, because it means that people are moving more quickly toward adopting 3D methodologies.
Yeah, and what do you see with the 5% that are closer to 100%? What kind of characterizes that type of utility, do you think?
Well, in general, those are utilities that in my observation have been having more success with their public involvement or public awareness campaigns. So as they go through and perform what can be perceived as very disruptive work to the community, by taking some of the fear, uncertainty, and doubt out of those projects. They're showing people in a very easily understood and contextualized way how a new transmission might be sited. They're showing how they're going to fit a substation within a mixed-use building in an area where space is at a premium or constrained. Dave, I think you've got some examples in your work where 3D visualization helps contextualize things like grounding, right?
Yeah, very much so. So being able to deliver something that is three-dimensional allows for much easier exchange of information between tools as well. So we can not only provide a better design, but also evaluate the reliability and safety aspects of those as well as how they interact with other entities. So pipelines, railroads, all of these other infrastructures that exist in our world can have some sort of interaction with our power systems as well. So being able to deliver something three-dimensionally kind of ties many working groups together and breaks down the silos between different engineering teams.
And PJ, let me ask you, we've got one other poll question that we're going to throw out to the live audience today and see what you all think. Do you believe that 3D models could help your utility in the future with design or operations and maintenance? And you can select yes, no, or unknown. And then Dave and Brad, I'd like you to comment on this once we get the results come back.
I think as Brad had mentioned before, this is something that's very much in the goals for many consultants and utilities, but I think it's just a challenge of finding the right opportunity to execute on that. So taking a guess at the percentages, we would expect that most people are anticipating that trend to go that way. It's just how do we step from where we are to where we need to be for this design process improvement?
Yep.
Yeah,
so
and it's validated.
A lot of optimism there, isn't there? 84% yes, yeah. So that's good. That's good. But those barriers, right? I mean, is it a matter of barriers, or that have to be addressed, or something else to fully achieve that kind of goal? What do you think?
Yeah, I mean, I'm really encouraged to see 84%. And if you add 96 total percent not saying no, I mean, the fact that 4% saying no is really, I think, impactful and emblematic of where we are. I think some of the challenges we have are very technical. And so those, I like to say once data is data, you can do anything with it. I think challenges that are technical, physics-based, math-based, I mean, they can be tedious, but there's always a solution to them. Oftentimes, it's going to be organizational change. Sometimes that means leadership changes within organizations. I met with a utility a couple weeks ago, and I'm meeting with another one next week, where they've admitted that because they've had some leadership changes within their organization, they are putting the gas pedal down on adopting technology, because now they see this as an opportunity to take this kind of overarching change and apply smart technology moves to their organization. This doesn't mean running with scissors, as I like to say. This means carefully, but in a more accelerated way, adopting these technologies. I think that's one area we're seeing it. I was really inspired at IEEE PES-T&D in Anaheim a few weeks ago when I got to see SoCal Edison's new head of innovation talk about her vision for her department and how SCE uses and leverages innovation and innovative thought processes to drive their operation forward. I think we're seeing a lot more of that. And I think when we see results to questions like we just saw, where 84% see it, I think that new mentality is really starting to percolate through these organizations. So we can work together to solve the technical challenges as a technology company with the organizational challenges on the owner, operator, and consulting side. Then I think we're going to be able to accelerate to where we're keeping up with this explosive demand for generation and energy source, and the need to create this next generation flexible, resilient, reliable grid.
Dave, do you have anything to add to that?
Just kind of bouncing off what Brad had mentioned earlier. We're running a marathon, you might need to stop and tie your shoes. That very much is applicable for this application, because you have less workforce trying to accomplish more in shorter duration of time, because the demand that's coming online is coming in faster than it used to in the past. So that means we need to be faster to supply the power for that aspect as well. I think those challenges in themselves are great drivers for people saying a better way to do something. It's just allocating our resources so that we can provide the teams with the resources that they need to do the work more efficiently. Every dollar that you're spending in preparation and getting a better tool is going to pay dividends as you look forward in the future.
Mm-hmm.
Let me just remind our live audience that we're happy to take your questions today. So feel free, as a question comes up, just type it into the question bar and we will get to as many of those as we can. Brad and Dave, let me ask, as we think about reliability and resilience, what is changing in core design practices that are used on a daily basis? What are some of the main changes that you're seeing?
Yeah, we're seeing, yeah. Sorry, go ahead, David.
Yeah, go ahead, Brad. Go ahead.
Yeah, we're seeing the incorporation of more insights and more data. And that doesn't just mean, dumping your SCADA system information into a design file. It means incorporating intelligence around things like how is redensifying urban areas to solve housing challenges impacting how you design the distribution system for an area. I mean, think about a lot of urban areas were designed to deliver a 100 amp service to a meter point and an address. And as cities go through a renewal process, now they're looking at dropping 4 200 amp services to support at-home EV charging. And that obviously changes the design constraints that have been used to create engineering standard books for almost 100 years. And so bringing data in like rezoning and being able to take that into account for how much capacities need to be generated. We have tools that automate subdivision design based on the most optimal and efficient way to place your pad mount transformers in the underground secondary. Well, that would benefit from knowing that the normal density paradigm needed to drive that automation has changed quite a bit. So we're seeing a lot more of that. We're also seeing a lot more incorporation of what I'll call a complete design, meaning that, in the past of just kind of doing rule of thumb based framing design, or, I just know that it's a straight line 3-phase primary circuit. I just kind of copy and paste the same thing all along. Well, now, given some of the impacts of weather that's taking place, you're going to have to do full co-rotational analysis on a pole. You're going to need to actually go beyond just using your engineering standard book to know that this framing unit looks this way, but to say, based on the soil condition, the new prevailing wind and weather, we're going to have to upclass this pole. And so actually running through, and a lot of that's enabled because doing that work is a lot easier than it used to be. You're not redrawing things multiple times. You're passing data back and forth. And that's the last thing I'd say is the integration of all of the tools that are involved, from project conception to construction as building. The fact that data can pass through every phase involved in that without having to be re-entered over and over again in ERP and GIS and all these things, that's allowing that acceleration.
Dave, what comments?
Yeah, and so just kind of jumping onto that too. So the way that we're assessing our infrastructure is also becoming more advanced in that when we're not just looking at a bunch of poles and basing their health based off of when we first installed them. There's a lot more conditions that we are looking at and evaluating when those poles may need to be replaced, when transformers need to be replaced because of overloading or storm surges that we might have had to withstand. So EPCOR is a good example of that, where Bentley provided the asset-wise tool, and that allowed their team to better assess what components of their system needed to be replaced more quickly than others. It helped in really establishing guidelines and goals for their team in far as setting up when we need to acquire new equipment and what type of work do we need to be planning for this next year. And part of that is that if you are just basing your replacements off of age, you're often reacting more often than planning. And that's not what engineering teams want to be doing, especially as we're trying to build something new. We want to be able to maintain the infrastructure that we've already built, as well as advance new energy to new places.
You brought along some other examples of how utilities are implementing new technologies. Why don't you take a minute and let's take a look at those and discuss each of those for a couple of minutes. You want to go ahead?
I think an example from Toth and Associates is probably a key example. Dave just said engineers don't like to be reactionary. He's exactly right. They don't. Dave is a PE. I'm sure you absolutely love being reactionary. Things, but sometimes we have to be. And severe weather events are an example where we need to be reactionary. However, the proactive part of that is being ready to address the unexpected when it comes up. So in this case, leveraging PLS's technology to have ready-made, readily executable models of existing infrastructure when it's taken down. In this case, 6.5 miles of lower voltage transmission structures in a remote part of Illinois that supplies power to 1,500 people. When this storm came through, using traditional methods of storm response and everything, probably would have led to about a 48 day to get their power back up based on pole availability, based on construction crew availability. I mean, there's been a lot of these really large scale weather events in the Midwest where I live in the last couple of years. And so even with all the mutual assistance or mutual aid crews driving in, it's still a big lift. Well, because they had modeled this overhead infrastructure already, and because they were using technology like PLS CAD and PLS Grid to coordinate this bringing back to life this transmission circuit, they were able to make decisions in more real time. So if a specific type or class of pole wasn't available, they could very quickly in a tool change that out, run analysis. And so not only were they just stubbing in like replacement infrastructure to make it work and get it back online, but they are restoring it in a way that doesn't require rework and expensive, going back and perhaps more planned outages to replace the temporary pole that was put up. And so, this is the using some predictive or getting ahead of it takes a little of the sting out of the unexpected. And this is just one example of where, adopting this technology a little bit ahead of time of the need is really helping utilities and the people who serve them get ahead. So the other one that I would mention is Copel. So we talked a little earlier about how there's a lot of change in where and how energy is being produced or stored. Copel in Brazil, they have a goal, as it says here, they want to ensure energy quality for 15,000 people. And in this case, substations, which are the connective tissue of the grid, in challenging geographies, typically where not only is the terrain kind of wonky, but it's a difficult operating environment. Certain areas are, very lightning prone. I think Dave can talk a little bit about how we use tech to protect ourselves from that. But there's a lot of need to perform this sort of design build process for remote locations when your engineers are, maybe as far as 7 or 8 hours away. So here they were able to use 3D visualization tools like LumenRT, using Bentley's MicroStation product and Open Roads to do the site planning, the grading plans, and these sorts of things, all integrated with Open Utilities and ProjectWise to create these pretty advanced, fairly decent size substation environments. And if you squint really hard, you can see in the top picture, including building walls and protecting critical, hard to replace, long lead time components like transmission transformers and things like that. So, in this case, again, they went to 3D. There's other examples we didn't bring with us today where they're using similar technologies for their hydroelectric facilities, not only for the raw generation of power, but also the long-term storage using pump storage technologies. But Dave, maybe you've got a comment on lightning protection in areas like this.
Yeah, I just wanted to make a comment about like these particular projects that have a lot of important infrastructure in one location, and being able to protect that from lightning is an exceedingly difficult task, especially in locations where there's a lot of strikes. Being able to three-dimensionally develop these drawings or this design allows us to better evaluate for all the different ways that lightning can sneak in and affect our system. Not only can it, hit a structure or hit your phases, but it can hit nearby, and all of that stuff can be evaluated using 3D design and then coupling that into analysis software so that we can do a detailed study from an electrical perspective and then figure out how our protective devices should actually operate in given certain conditions. So it's a way that we can collaborate with our civil team, with our physical team, with our PNC. It really ties all the teams together.
Yeah. And I want to add one thing too, David, to this. This may all appear very aspirational to members of our audience, but I want to tell you this is becoming the norm. So more and more utilities, the engineering firms, engineering consultants, and so on are adopting these because they can see it as a project accelerator, reducing time to market. And 10 years ago, scanning to get the base ground elevations or doing brownfield work was extremely expensive and time consuming. But a lot of that scanning equipment, photogrammetry or ground-based lidar, or even drones, it's been so commoditized that it's so much more approachable. And it may be that an investment in some of your own equipment to generate that base level of data that's used to design in this way is paid for, 20% into one single brownfield project. So, we talk about emerging technologies a lot. A lot of what we're talking about today isn't emerging, it's maturing. And what's emerging is how it's being used to solve these problems. So again, Dave talked about engineers. We like things that are proven. And what we're talking about are things that are proven, but using them in a more interesting way to solve these difficult engineering challenges.
Mm-hmm. At the same time, there's some constraints that remain in place that need to be addressed. And what new challenges related to constraints are there, and how do those how are those addressed most effectively?
Dave, any constraints from an engineering perspective you want to add first, or?
I think
yeah, a little divergent view of what some of those are.
But I would interpret when I hear about challenges is that this new digitalization of our power system adds a lot more data to our power systems. And that data needs to be actionable. We don't want a lot of data that's not something that we can interpret anymore. And the ways that we're doing that, well, thank goodness for this evolution of the AI, that's one methodology, and that we can have OCR that can recognize different components of our electrical power system, categorize that, then we have our bill of materials automatically for that and reduces our human labor that's needed for that type of work, as well as being able to have tools that can automatically connect all that information. Like Brad had mentioned, the LiDAR and photogrammetry, all of that information is a lot of data. We need tools that can automatically connect that in there. So you can use tools like ProjectWise in order to put in all this information. You can even pull in metadata from that to determine what type of equipment you have out there in case you need to be resilient for a storm. Your storm season is coming up. What components do you anticipate failing, and what do you need more of? That's kind of what I jump to when I hear about the kind of challenges that are growing. I know Brad, others.
No, I think you touch right into where I was thinking too, is about data, the quantity of data that we're accumulating, but it brings about a couple of thoughts. You just mentioned the management of it. I think one of the challenges is that there have been investments in disconnected bespoke technologies, many of which were developed in-house, which is really, really great, especially when there wasn't a commercial off-the-shelf solution for what people were trying to do. But I think a lot of utilities are grappling with the overhead costs for those, especially as the people who created those tools retire. And so with them goes a lot of the institutional knowledge on what it was taking, not just to kind of nurture and curate it as it goes forward, but just to maintain it when something inevitably goes wrong, the next Microsoft Windows update or something like that. So, that's one part of it, the interconnectedness of the applications or capabilities that would benefit from seeing that data. But I also think there's a bit of a, and this might be controversial, somewhat of an inferiority complex that exists in our industry about data quality. I think back to when GIS was really, really taking off in utilities, and especially when it was not just being created conceptually, and people were standing up their GISs, but it's when we started to think about how do we use GIS data in other systems and solutions. And I always heard, well, our GIS data is not good enough yet. But when you really dug in and talked to the GISPs and you talked to the GIS administrators and you talked to surveyors and engineers, you found out the data was actually very good for the purpose they needed it for. I had a distribution designer ask me if we could place an element on a map with sub-decimeter accuracy. And we're talking about like 60-foot class 2 poles. Like we're talking large, I think it was large poles. And I asked them, what is the laser accuracy for the pointer on your pole setting truck? And he's like, well, okay, that's actually a pretty good point, because they're going to dig a 2-foot or 3-foot hole. And I mean, you want to be close, you want to have precision. So, one of the things that has stood in the way of many utilities from adopting this is this analysis paralysis, or perfect being the enemy of good. I think, pick your other favorite corporatism for the same kind of concept. I think that's been a big barrier and challenge for a long time. And I think utilities, and we're not saying just like throw caution to the wind, but because we're able to use tools like the iTwin to contextualize data, we're able to say, hey, this information is useful to this level of precision for me to make my decision. And if it's not sufficient, then you go and verify it. But if it is, you proceed and you move forward. So I think that's another thing that's been a barrier. And thankfully, utilities are starting to find ways to overcome that very traditional barrier to leveraging these technologies.
Sticking with this discussion around data, what can you say about derivative work from design processes, and how does the data affect those tasks as well? Can you talk a little bit about that?
Yeah, happy to. It's the data not drawings concept. Forever we've created drawings of everything. I was having a conversation with somebody yesterday. They're trying to find a way to digitize 20,000 drawings of substations or substation components. That's a lot. And I think that's going to be a big task. They have to do it. But once it's in a data format, it's data is data. You can do anything you want with it. You can pull it into Excel and use Excel magic to do insights. You can bring it into a data lake and mine it for insights on how long has Westinghouse ABC components, how long are they lasting in service? Do we find that GE so-and-so transformers tend to work the best? Once this information is in a data format, you're able to do so much more with it. I don't know if that's the spirit of the question, but that's what we're seeing, is that data is unlocking a more intelligent way of addressing these challenges and performing this work.
Just going to bounce off of that 100%, where we don't want to be, I guess when you first start in the engineering career and then you see the massive plotters and printers, it's a little bit surprising, being in the day and age that we are, that we have so much advanced computer technology that we're going back to print things on paper, send it off to the field for somebody to field install that. We have a lot better ways that we can transmit the information for what things need to be installed on the design side, on the build side, to optimize our power system and really meet the challenges that we have, that we can take advantage of those, and they're already mature technology. We just need to find opportunities to execute on those.
Yeah, and I should temper what I said with one additional detail. Drawings don't go away, but it's not the end-all be-all storage of information anymore. Drawings need to be able to be created for the user in the context that's most relatable. A construction crew is still going to need some depiction, likely a drawing, sometimes a print. I mean, I stood up at IEEE in a panel and I held up a notebook because I was talking about the need to stop writing things down on paper, and that wasn't lost on me. And so I think it's getting it into that data format enables a much easier process of getting it into the drawing format that it's needed. But we gotta start thinking about generating the data that then the derivative is a drawing or a depiction or an interface to another system where the data is used.
Yeah, we want to avoid copy paste on page 17 to page 30, 300, 500, 512. Like, what we want to do is change one thing, and that's going to propagate through the rest of our design.
Yeah. Is there can you talk a little bit about the strategy that utilities and their partners might want to take to make the best use of data? How do you avoid, constant improvement churn that often you see in the GIS? What are the steps to follow?
Change management, and having a change management methodology as you embark on it, which means don't constantly change. I think of kind of an agile methodology, but maybe prolonged sprints or prolonged epics, where you say, we're going to do this thing, we're going to do it this way. And even though along the way we might find another way to do it, let's get this thing done and then apply what we've learned along the way to the next iteration or version. Now, that said, that doesn't mean have a 5-year plan to make one small change. It means look at things on 6 and 12-month chunks or 3-month chunks, depending on what it is. I think identifying what that that bite size amount of change can be is a key part of it. And I think driving alignment across a group, an organization, or a collection of colleagues on something you want to do is super key. And these are all human factors that are impacted by technology. And I think it just shows that as much as we all talk about technology, there's still a process component to this. And there's the old saying, you can pave the path that was wandered through, to make. It's not a good approach to it. Applying technology to an old way of doing things is sometimes not the best way to get the outcome you want. You have to also evaluate your process changes.
And I just want to bounce off of this too, since it kind of reminds me of Essential Energy. I think it's Essential Energy down in Australia. What they did, they had an actual problem that they needed to resolve. So they have a very large network, almost 1 million miles, almost 1 million kilometers of conductor out there, but very low population density of that. And so they have this challenge of being able to supply power for all these individuals with a relatively low number of people to support their work. And in order to do that, they got smart in how they're approaching their problems. They had a challenge that needed to be addressed for all of their stations. They created a pilot, not for the purpose of creating a pilot, but that is the way that we can build better on our next 3 or 4 projects for the next 2 years. And so they had multiple challenges to meet. They had to get information about existing sites that may have been lost over time because they just had scans, or they had hand-drawn designs that just got lost and were not rasterized or digitized. They also needed to improve the reliability for lightning performance challenges. And they could do all of that just by going out there with a drone, scanning the site, understanding the equipment that they have. That allows them to do a digital model of their system. And now they have addressed the challenge of lightning protection, but also created a new way that they can design their system. And these designs can be updated by their local design team and then passed to their construction team the same day within this digital format. So their ability to do that reduced their cost to design and reduced their cost to delivery, and also just reduced the cost to travel from one place to another because you had all the data on your first site visit. So those are huge advantages when you think about being able to digitize all the information that we have.
And if we think about the larger mission associated with that, it's greatly impacting the quality of life for these people who live at the outer reaches of their system, where they're not waiting because it's 580 kilometers round trip to visit the sub to do the work. They're getting the power restored right away, or they're getting new capacity added in a more timely manner. And it's de-risking for the employees. Safety culture is very important in our industry, and reducing the amount of time people have to spend driving long distances to perform routine work puts them in a much safer position away from people who maybe aren't paying attention while they drive. So there's a lot of tag-along benefits that to all of these different initiatives or ways of adopting technology that go beyond saving time and money, improving safety and KD scores, or complying with federal or state regulation.
We've had a question come in from the audience asking about AI and what role AI could play in creating digital twin solutions and in advancing some of these solutions that we've been talking about. Brad, what do you think as a start?
Sure. I think there's a lot of promise with AI and machine learning in helping accelerate the work that's being done. Where I like to take a very practical view on a lot of these technologies, whether it's that, VR, augmented reality, et cetera. And to me, using automation, human-assisted or human-supervised automation to automate the routine and tedious is the most likely first place it's gonna take effect. I use an example of automating the layouts of new subdivisions. What's the most optimal place to put a pad mount transformer and run secondary? A user is still driving that process, but it's taking the manual calculations out of the equation. There's a lot of those sorts of things. So You could take the very futuristic approach and say, I'm going to push a button, now I get a 345 kV transmission substation at a GPS lat long. Maybe we're not that far from that, by the way. But I think the most practical and near term is going to be those human assist, over the shoulder sort of scenarios where automation. Now, as we glean more insights, more opportunities, or more things become more practical. But I think in our industry, it's probably the most logical place to start. That and other, we think of OCR as being somewhat new. I would say OCR's been around for a long time, but the depth and capability of OCR technologies today to digitize old drawings and nameplate data and those things, that's gotten a lot better because you're now adding context and insight to that OCRing process versus just very simple, computer identify letter sorts of scenarios.
Mm-hmm. Dave, your views on AI?
Very much in the OCR type of aspect of that. Like when we looked at the essential energy, you could actually zoom in and see the nameplate of the transformer, and that information could be absorbed into your power system model. And that can tell you how your fault characteristics are going to look like for your power system, how you should operate for those given fault conditions, whether your equipment is over duty because of that. There's a lot of information that you can glean with having kind of a computer assisted reading capability, and being able to identify those challenges. Even simple things like, what type of ventilator do I have on this particular line? That may not have been characterized very well on a part of the initial design done 60 years, 70 years ago, or some of these transmission lines that need to be redesigned. Identifying that information can save significant costs in a project if you are able to determine if that's sufficient or those are all end of life. So that type of information and having AI to assist with that is something that Bentley is certainly working towards, and already implementing in many instances.
Yeah, I'll give you another example. Over my shoulder, I have a sign that I found at a flea market near my house. Northern States Power was at one time the name in front of our utility. It's Excel today, and transmission lines and other corridors are more and more are frequently being imaged and LiDAR captured as a part of their FERC vegetation, ensuring hard clearance project work. But being able to detect, yellow rectangles in all the imagery is going to point out potentially non-compliant signage, and so it helps them stay ahead of what compliance requirements are around signage if those change over time. So imagine being able to scan your entire system's imagery library when you find out that the regulation has changed for what your safety signs have to look like, and it just going through and telling you, here are all of your non-compliant signs so you can create a program to replace them. There are these sorts of ideas on how automation is going to come into play to do this sort of detection. Now, that's identifying the difference between a sign like this and somebody illegally attaching a for sale sign or a no trespassing sign for their deer stand. It's important that automation helps take some of that judgment so that somebody's not having to sit there and click through every single image. These are some other practical examples.
Another question from the audience, audience members wondering, in your 3D modeling examples, are you utilizing multiple modeling tools or one in particular? Can you talk a little bit about that?
Dave, why don't you take it first?
Yeah, I was going to say the Open Utility Substation is definitely an example, and that Copel example, as well as LumenRT, is a good way for illustrating your concepts for more non-engineering audience as well. It gives nice visuals for illustrating how this power system will interact with your urban facility, your urban area, or just affect your skyline, for instance. Those are kind of the couple that come to mind. Brad, do you want to?
Yeah, so in addition to the specific products that are enabled with 3D views like MicroStation, Open Roads, Open Site, etc., we also have different formats for 3D visualization. So it could be used in the design process in a design tool like Open Utilities or MicroStation, but it's also used in browser environments where it's democratized across an organization so that other people have the ability to view and glean insights from 3D data. It can be leveraged in, say, AR/VR for training, which we're seeing. If you have a chance to go out to the Bentley website, you'll find Essential Energy's video showing how they're using 3D visualization. Another area we're using it for is to gain insight during project execution. So Minnesota Department of Transportation uses 3D visualization, and in the case of the Elk River project on 169, which is very close to my house, they were able to project forward and save $500,000 in dirt work and 58 miles of utility relocation by seeing not just where things were in design or as is, but as a project proceeded through time, how they might change project constraints or design constraints in 3D as it interrelates to other infrastructure in a corridor.
What if you could talk a little bit about the role that policymakers play in encouraging the adoption of new and emerging technologies? How important are regulators and other policymakers in all of this? Brad, take a first chat.
Yeah, crucial. They're absolutely crucial. Utilities take the regulator's stance and statements very seriously, and it drives a lot of behavior. It drives almost all behavior within an organization for what they do and do not adopt. So policymakers, I think, have a duty to be very clear, concise, and complete in their communication of direction. So thinking about cybersecurity rules, it's important that they're very clear and very concise in how they describe things. There's been some confusion on some of the rulemaking outcomes that's being addressed, thankfully, which is really great. There's good public-private partnerships that are helping to accelerate that alignment and adoption of the intent of the rule. I also think from a policymaker perspective, it's important to look at the full scope of what it takes to affect the change or the outcome that a specific policy is intended to. So it's very easy to just consider the big bridge that'll be built or the large poles that are put up and the cost of the steel and concrete and labor that goes into it. But considering the cost and contribution that technology can have in how they budget or incent or fund projects is just as important. So as new initiatives are conceived, thought of, and then codified through the passage of laws or the issuing of grant programs or the writing of rules, it's important to think about all these different aspects that come into play to bring the result that's being sought, that it's not just about concrete, steel, copper, wire, and just the human factor of bringing it to life.
100% to jump off Brad's comment. There is a, when you go to these IEEE events and talk to the engineers about some of the challenges that they have for changing the way that they're doing things currently, one of them is just how do we associate the cost of a new tool with being able to better approach our problems that we're dealing with. And that capability and giving some roadmaps for utilities to deal with that is a huge benefit toward the utility, the users of that power as well. So it's really one of those situations where everybody's winning and we're able to more efficiently design our systems with better tools and address our goals in the end. Another one too is, I was just gonna say, like making sure, like when you're looking at the scope of these, that you actually have the supporting personnel or processes to do that, whatever permitting may be necessary. Those are ancillary challenges that Bentley has several tools of support with the geotechs and their investigations for water quality and all these other aspects that may not be very transparent when you kick off a project.
Yeah, and we are, to put a hopeful piece to that, we are seeing organizations like the U.S. Department of Energy really adopting a more clear way of articulating this and a real embracing of technology and its role in the energy landscape at leadership levels, which is really great. So seeing some of the career folks within DOE get out in front, talk about technology as an enabler and accelerator has been really, really encouraging these last few years. And then on the finance side, seeing accounting rules allow for capitalization of technology the same way they might a piece of equipment being put into service is also serving as an accelerator. Now, it's up to utilities, accounting departments to understand and have their auditors and underwriters articulate that in their financials as well. But we're starting to see that convergence on enablement, which is what I think we all want at the end. So,
Dave, let me ask you to weigh in on this first. We've covered an awful lot of ground here today, and I wonder if you could offer just a few takeaways of what utilities engineering firms and policymakers, what do they need to keep in mind as they're moving forward or looking at this journey with technologies that we've been talking about today? What are the key takeaways for you, Dave?
For me, it's really about improving our tools to better utilize our personnel that are lower number of personnel, as well as being able to better utilize our funding. We have a lot of funding that's going into this, and we don't want to squander that because we do have 2 to 5 times the amount of energy that we need to supply and provide. So supply, deliver, and consume. So there's a lot of pressures that are driving us to use more intelligent approaches for how we are building and designing and operating our power systems.
And Brad, your takeaways?
I think it's a couple of key things. Number one, we've been talking about emerging and new for a long time. I think it's important to recognize that a lot of what had been emerging 6, 7 years ago is current tech. And it's incumbent on us to look at a lot of these technologies and process changes as proven and to figure out how do we integrate them into our practices. Having a partnership, a true dialogue with your regulator or your policymakers in your area to help educate them through organizations like Edison Electric Institute or NRECA if you're an electric cooperative. I think that's a very key thing to do. I also think there's 2 other things. I think having an eye on how you're enabling and attracting this next generation of utility professional is going to be very key, remembering that their expectation of work and technology is not driven on a B2B interaction. It's a B2C interaction that they have on a daily basis on the smartphone. We need to consider that. And lastly, I think it's having an open, candid, and innovative dialogue with all of the different stakeholders within the industry. So if you're an owner operator of infrastructure, having an open, honest dialogue with your technology providers, with your engineering firm partners, with experts in the industry, and then being present and collaborative in our industry is we're seeing that those utilities are the ones that are coming out ahead in many different ways. So I guess those are my key takeaways I shared today. Happy to have a coffee or a frosty beverage with anybody who wants to go into more of them, but those are the ones that rise to the top of my mind.
All right, sounds good. That's all the time we have for today. Dave Lewis and Brad Johnson, thanks very much for your insights. And thanks again to Bentley Systems for sponsoring today's event. One note for our audience, watch for an email from us containing a link to the replay, and please take a moment to complete our survey at the end of the session. Your feedback's always greatly appreciated and will be used for future sessions. From everyone at Energy Central, I'm David Wagman, thanking you for joining us, and we look forward to seeing you on an upcoming session. Thank you for attending. That concludes today's presentation.